All right, welcome. Today we are talking about composite transformations and symmetry. So we already talked about transformations in that we are taking a geometric figure, an object on a graph, and we are altering it in some way. So before we talked about translations, reflections, dilations, and rotations. To perform a composite transformation, you're basically just going to perform two transformations on the same figure, one after the other. So basically our image is going to be sort of a third figure on the page. So if we look at the practice example that they've given us, we have triangle JKL, and we need to take the points of JKL, create an image by translating on the vector 0, 4, and then reflecting across the y-axis. So we probably want to start off by just plotting the points, right? So we need 6 and -1. We need 10 and then -2, like over here. And then we need 5 and -3. All right, so here is our initial triangle. Let's get that in blue. And there we go. So again, we need to translate it, we need to transform it twice. So our first translation is going to be a translation of 4 units on the y-axis. So again, the vector is telling us first whether we need to move side to side. And so if I'm moving 0 spaces on the x-axis, everything's going to stay where it is. Then we're going to move 4 spaces on the y-axis. So 1, 2, 3, 4. So all of my points 4 are going to be 4 points higher. Something like this. And then for the second transformation, we're going to reflect on the y-axis. So again, we're going to go across 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So we're going to put our point over here. So we're going to count 1, 2, 3, 4, 5, 6 spaces to the axis. 1, 2, 3, 4, 5, 6. And then of course our final point was 10 spaces from the axis, so it's going to be 10 spaces on the opposite side. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10 would be about here. Let's get my line. So our final image is going to end up right about here. So if we are labeling our points, we know that we started with J. J was over here. K was over here. L was over here. And then our final image was after both transformations. So the green triangle is going to represent our image. So we're going to have J prime over here, K prime over here, and then L prime over here. So you can do the same thing with rotations or reflections or any combination of the transformations that we've discussed before. Just take the figure that they've given you and follow the directions in the way that, in the order that everything is given to you, and you should get the correct image. So the next So the final concept for today is symmetry. So you may have seen symmetry before. Basically, this just means that you have a figure where you can draw a line through it and create basically two equal halves. When we fold one half across the line, it should line up exactly with the other half. Another way of saying it is that the line of symmetry cuts the figure so that you can reflect one side across and everything matches up. So if you're looking at this little figure right here, the line in the middle is our line of reflection, our line of symmetry. Since we're reflecting across that line, this is reflectional symmetry. So if we look at these three pictures, we can see that the crab has one line of symmetry going down the middle. We see that the starfish actually has a number of symmetrical lines. And so if we're counting it, we have 1, 2, 3, 4, 5 different lines of symmetry. Right? Because there's 5 edges of the star, and the line of symmetry not only can go through one of the edges of the star, but also the corner where the two little legs of the star meet. Of course, the oyster has no lines of symmetry because there's no way to cut this thing to where it's going to fold over properly. Finally, rotational symmetry. So this basically means that you can take the figure and rotate it in such a way that you wind up with the same figure. So the center of symmetry, or the point of symmetry, is basically at the middle of the figure. That's where we're going to rotate around to create our identical figure. So the example they give you here is a square. We can rotate the square 90 degrees, and it winds up looking like the same square. If we rotate it all the way around 180 degrees, you get the same square. 270 degrees, same idea. But if you only rotate it 45 degrees, the square ends up flat instead of tilted. So these are different things to look for when you're looking at your rotational symmetry. So if we look at these three shapes, we have a hexagon, a triangle, and then just sort of a general figure. We need to figure out whether or not they have rotational symmetry. So to do that, what I'm going to do is trace the figure first. And then what I'm going to do is copy the image, and I'm going to rotate it around to see if it ever overlaps with the figure again. And I notice right here it does. Right, so this figure does have rotational symmetry because I was able to rotate it around and get the exact same shape. Question is, how many degrees did I have to rotate it to get it to fit? Well, let's look at the number of sides in the figure. And let's get a little dotted line to make this a little easier to see. So the center, we just sort of rotate it around the middle. So let's take a point in the middle and draw lines to each of the vertices. That last one didn't come out perfectly straight, but as you can see, if I cut at each of the vertex points from the center, I create 6 equal spaces. We also know that if I start at one point and rotate all the way around, right, that's a full circle, so 360 degrees. Well, if each of those 6 sections is equal. Divide that 360 by 6, and that tells me I can rotate 60 degrees to get the same figure. All right, so if we do the same thing with the triangle, see if we can get a rotation here as well. There we go. Let's just do it with the pen. Alright, so this won't be perfectly straight, but it'll do what we need to do. Alright, so there's our triangle. So I notice as I'm rotating, it's never really lining up the way that it should until I go all the way back around. So the triangle that we have here does not have rotational symmetry. So we've got one more to look at. It's this little wavy figure here. So again, we're going to trace the figure. Highlight it. Alright, so let's see. If I rotate around, notice I went clockwise. Before I went counterclockwise. It doesn't really matter. Basically, the idea is you just want to rotate until it matches back up with the figure. And it looks like when I get about here, if I had drawn everything perfectly straight, it matches up. So notice the little ball that I was using to rotate the figure, it was on top. Now it's on the bottom, so I had to rotate half a circle, which is 180 degrees. And that's rotational symmetry. Alright, that's all I have for today. I will see you guys next time.